Hello, my name is Greg Buol. The poster presented here looks at the Microsoft Excel-based peanut risk tools which have been developed for North Carolina, Malawi, Ghana, and India. Work has also started on the development of an Argentina peanut production risk tool. 3 years ago at North Carolina State University, work began on the development of a computer application which would handle the existing web-based North Carolina peanut risk application and would facilitate the development and use of risk tools specific to other peanut production areas around the world. To accomplish this, a widely adopted and relatively simple platform needed to be selected while providing enough programmability to manage the risk indices developed to represent the diverse peanut production systems found around the world. Microsoft Excel, with its built-in VBA programming environment, was selected for the development platform. Using Excel, data entry and editing forms were developed to create and maintain the peanut risk tools. The developed Microsoft Excel-based application has worked well for the peanut production systems for which risk indices have been developed. Furthermore, it has been robust enough to handle the relatively complex production systems found in North Carolina and India. The risk tools for these two locations and the Argentina risk tool under development evaluate multiple pest risk indices for such pests as arthropods, diseases, nematodes, and weeds under a range of production factors and practices impacting each pest. Examples of some of the production factors and practices covered in the risk tools include pest and crop history, planting date, variety, soil properties, pest control practices, and harvest conditions. The Malawi and Ghana risk tools focus on management practices and how they impact yield and aflatoxin contamination. To evaluate potential aflatoxin risk, practices associated with drying and post-harvest handling and storage are included. For Ghana, 3 risk tools were developed to account for the northern production region and the 2 production seasons in the southern region. In addition to evaluating management and pest risk to yield, each of the developed risk tools provides information on the cost associated with selected production options. Although the primary goal of the peanut risk tools is to assist growers and their advisors in identifying the best production practices to minimize pest risk and maximize yield for their production systems, the tools have been beneficial in other ways. The tools have been useful in classroom instruction by providing instructors with a way to demonstrate the importance of how individual management decisions impact risk to yield by multiple pests found within a production system. They have also been useful to research and extension teams as they collaborate to identify knowledge gaps for pest complexes and update production recommendations as new tools and pests are introduced into a system. Finally, the risk tool framework has proven to be flexible enough to handle diverse peanut production systems, as well as allowing risk tools to be modified to account for new production practices and pest indices. Thank you for your interest in the peanut risk management tools.